Hi, Year 12. This is my attempt at Topic 5, Key Assessment 2. Hope you're all well, and let's have a go at this one now. Now, this one is all about evidence for global warming. You looked at 3 different things in the lesson on this, and this one is the pollen analysis. So climate change has been correlated with a changing atmospheric carbon dioxide levels. Scientists studying climate change have examined peat bogs to observe pollen grains such as those shown in the photograph. Explain how studying pollen gains in the peat bog can provide evidence for climate change. Okay. Explain means biology. All right. How studying pollen grains in peat bogs can divide. So the first thing to do is these pictures, these diagrams are not just here for show. Okay. They might better tell us something. And the clear thing that this is showing is that everything is different. Okay, here, all the pollen is different. And if it's different, therefore, it's going to equate to it being from different species. And that might be relevant in our answer in a minute. So, what is pollen analysis all about? Well, the first thing to say is that, obviously, it's happening in peat bogs. Okay, and the relevance of the peat bog situation is this idea that it gets preserved. Okay, it lacks oxygen, and therefore it preserves the pollen. Now, we've looked at the different species here. Okay, so the different species can be identified. Okay, so by looking at these different pollen grains, we can work out what species were around when that pollen was deposited. Okay, and the other thing about that is that different plants are going to grow in different climates. Okay, we're not going to get Brazil nut trees growing in this country, for instance, at the moment. So you're not going to find pollen around at the moment for Brazil nut trees in England, but you might find it in Brazil, and potentially you might have found this further back in time. Now, how do we know about when this pollen was deposited? Okay, that's all about depth. So the deeper the pollen, the further back it was deposited. And we can do some work on this, like carbon dating potentially, or even just knowing about depths to see when that pollen was deposited, and therefore when that particular species was around. And then we can see that if these pollen grains change, if there's a change in the species over time, then it indicates that the climate has changed. Now, climate's quite a broad thing, okay? That could be talking about temperature, could be talking about water availability, could be talking about all sorts of other things, but it says can provide evidence of climate change. So, we need to talk about preservation, the idea you can identify different species, and that is dependent on the climate. The depth will give you the age, and if you're seeing changes in that pollen over time, then that's going to indicate climate change. All right? Good. A bit of maths. So, scientists measure the productivity of 2 types of forest and recorded the mass of carbon taken up per square metre per year. Okay? So as soon as I see those units, I'm thinking GPP/MPP. The table shows data on the mean net primary productivity and mean gross primary productivity of these 2 types of forests, so I'm thinking correctly. All right, then we've got some data in there. Calculate the percentage increase in mass of carbon released due to respiration by temperate deciduous forests compared to that of boreal forests, okay? Now, we haven't got respiration, have we? We've got MPP and we've got GPP. So we need to find what respiration is. MPP equals GPP minus R. Okay? So how are we going to find R? Okay, we need to get R on its own. And we're going to find R, okay, by looking at, take that onto that side, so GPP minus MPP equals R. So if I work that out from those tables, I can work out my R values. So for boreal, okay, my R value is going to be 1013 minus 322, which is going to give me 691. And my R value here is going to be 2165 minus 1301, which is going to give me 864. So there's my values for respiration, okay? I've then got to do a percentage increase, yes? So that gives me an idea that the smaller number is going to be on the bottom of my fraction, all right? So on the bottom of my calculation. So when we're looking at percentage increases, we're going to do the difference over the original times 100, okay? So the difference here, all right, is 864 minus 691, okay, over the original. We're going to increase, so we start with a smaller fraction, which is over 691. That equals 173 over 691. All right, and that, I believe, is going to give us a value of around about 25%. Right, 25.04 slash 25%, okay, for your nearest whole number. Really important you look at that, okay? That percentage increase, percentage decrease, percentage change is always going to be a thing, all right? And it's important that you get the original on the bottom, the right number, okay? If we look at an increase, we're always going to go from the lower number, yeah? And last but not least, ratio of net primary productivity to gross primary productivity is a measure of the ability of forests to transfer carbon from the atmosphere into the biomass. So how are they transferring atmosphere into biomass? That's photosynthesis, okay? All right, you photosynthesize, you produce organic compound, and that increases your biomass. Scientists concluded that temperate deciduous forests would reduce levels of carbon dioxide in the atmosphere more than boreal forests. Justify. So why is that true? Okay, now, this is where this is absolutely key, okay? This is absolutely key. So photosynthesis is what's going to increase the biomass. What bit of this is photosynthesis? That is the net primary productivity. That is the bit of photosynthesis that goes towards increasing the biomass effectively. All right, and from that, all right, we can see that the ratio of NPP to GPP is greater in temperate deciduous forests, okay? That means effectively that the NPP is higher, which therefore means that more carbon is going to biomass than is being released by things like respiration. Okay, so more carbon is going into that. What does that mean again? Well, that means that more of the carbon that is being taken from the atmosphere is contributing to photosynthesis compared to being respired. Okay, so for whatever reason in these temperate deciduous forests, more of the CO2 that's been taken out of the atmosphere is going, by photosynthesis, is going towards biomass than is being used for, being released by respiration. So if it's not being released by respiration, it's contributing to the organic compounds being produced, and the biomass of the plant is increasing. Okay, hopefully that's useful. Any questions, give me a shout, and we can maybe go through that in a Teams meeting. Good luck. Hope you're well. Bye-bye.